In this video, I'm going to teach you how to implement the Decorator pattern using the Scrutor library, and the goal of this pattern is to extend the behavior of your classes without changing the original implementation. I'm going to use the Decorator pattern to extend the behavior of the member repository class to introduce support for caching of the getById and the getByEmail queries. We're going to use the Scrutor library to add support for dependency injection so that our clients can still use the iMember repository interface, but at runtime we're going to provide the caching Decorator implementation of the member repository. So let's see how we can achieve this. I'm going to add a new class in the repositories folder, which I will call caching member repository. This class is also going to implement the member repository interface. So let me add the iMember repository interface. I'm going to stub the definitions for all of the methods inside of this interface, and then let's see how we're going to implement them. I'm going to start by injecting an instance of the iMember repository from the constructor. This might seem a little confusing. We're implementing the iMember repository, but we're also injecting the iMember repository at the same time. How this is going to work is we're going to wire up both the member repository and the caching member repository as the implementations of the iMember repository interface. And then we're going to use Scrutor to decorate any existing implementations of the iMember repository interface, which is the base member repository in this case, with the caching member repository class. And if I inject the iMember repository in the constructor of the Decorator, and in this case this is the caching member repository, I'm going to get the existing service registration for this interface, which is going to be my member repository class. So basically this member repository here represents the member repository implementation that we already have in place, which means that I can go ahead and implement all of my interface methods with the base implementation. So this is what I'm going to do. I'm just going to delegate all of the implementations to the base repository before I extend it with caching support. So let me just add the calls from my base class to the caching member repository implementation. In the isEmailUnique method, I'm also going to call the member repository implementation of this method, and I'm going to do the same in the calls to the add and update method. So we're just calling the base member repository and then delegating the call to the existing implementation of the update method in this case. So this takes care of implementing the caching member repository, and you'll notice that this approach does lead to some code duplication because your decorating classes have to implement the base interface. If you were using inheritance, you could mark some of these methods as virtual and then override them in the Decorator implementation, but we don't want to use inheritance, and in this case we are using the composition approach, where we are composing over the base member repository implementation and then extending it with a decorator. Sometimes you will also hear that this approach with injecting the base interface in the constructor is actually the proxy pattern and not the decorator pattern, but so many people are using the decorator pattern name that I think it's not incorrect to consider it an implementation of the decorator pattern. And you'll later see that the Scrutor library also references the decorator pattern to implement this approach. So now that we have our caching member repository, let's extend it to actually support caching. So I'm going to use a simple approach with the iMemory cache interface, which is available in .NET Core. So let me inject the memory cache from the constructor, and this is just going to store any cached values in the available memory on our web server. And I'm also noting that this will not work in a distributed environment. So as long as you have one application server, you can use the iMemory cache approach. So let me show you how to introduce caching in the getById async method, for example. We're going to take out this call to the base memory repository and replace it with a call to memory cache, and then I'm going to call an extension method which is called getOrCreateAsync. This method accepts two arguments. One is the key that we want to use to know which value we are getting from the cache, and I'm going to generate the key using string interpolation, and I'll specify member and then the ID that we get in the argument of this method. This allows me to uniquely identify this value in the cache. And the second argument I need to provide is a factory function taking in a cache entry and returning my actual cache value. So let's grab the cache entry and define the body of our function. So here I can just go ahead and return the actual value from the call to the member repository. This function is going to trigger when we encounter a cache miss, so the value isn't available in the cache, and we are going to head to the database and query the value directly, and then the memory cache is going to cache this value before returning it from the method. We also need to set an expiration time by calling cache entry and then calling the set absolute expiration method. So let's say that the expiration time is 2 minutes from the time that we first cache the value. If you hard code the value like this, you have to repeat it in quite a few places. So a slightly better approach is to define a generic cache time at the class level. So I'm going to add a field, which is going to be private, static, and read only. It will be a time span, and I'm going to call it cache time. And it's going to be time span from minutes, and the value will be 2 minutes. And then I can use the cache time that I defined here in the set absolute expiration method. One more thing that you can clean up is the hard coding of the cache key if you ever want to reuse it in more than one place. So an approach that I like to use is to create a static class that I will call cache keys. And then inside of this static class, you can define your individual cache keys. So let me make this class public and static, and let me define my public static cache key. So I'm actually going to use an approach that returns a function, and this function returns a string. Now this function will need to take in a GUID argument, which is going to match my member ID, and let's call this cache key member by ID. Let's give it a value, which is a function taking in a member ID and returning the same value that we used previously for generating our cache key. So now that I have this cache key as a function, I can go ahead and use it in my caching member repository by replacing the hard-coded value here with cache keys. Then I call member by ID, which is a function, and I'm going to pass the actual member ID value and get back the formatted cache key that I can pass to my memory cache. This is something that I will commonly use in my applications, and let's see how we're going to apply this same approach to the get by email async method. I'm going to start by calling memory cache, and then I can call the get or create async method. I'm going to use my cache keys class to grab the member by email cache key, which I currently don't have, and it's going to accept the email value as the argument to generate the cache key. Then I'm going to define my factory to obtain the member, which is going to give me access to a cache entry. I'm then going to use this cache entry to set the absolute expiration time, which is a field that I have defined in my caching member repository. So let's pass the cache time value, and then I can just return member repository get by email async. And calling this method, we'll head to the database and obtain the user by the email if we encounter a cache miss. Let's also define the respective cache key. So I called it member by email. So this is how I'm going to define it in the cache keys class. I'll say public static function accepting an email value object and returning a string which represents the cache key. We'll call it member by email, and we can just write a simple function to generate our cache key. So let's say that the cache key is member email and then the email value converted to a string. Because the email is a value object, I'm going to access the value through the value property. And now our caching member repository should compile, and it's going to properly cache the member by email when accessed for the first time. And now let's see how we can wire everything up using the Scrutor library. I also need to make sure to include the required services for working with the memory cache interface. So let's head over to my dependency injection setup, and let's head over to the call to add persistence. Here you'll see that I'm calling services add memory cache, and this is going to take care of adding the required services so that I get the proper implementation of the memory cache at runtime. And what we want to do is to update this call here, which registers the member repository as a scoped service, to add support for the Decorator, which is our caching member repository. I mentioned that I'm going to use the Scrutor library, so let's go ahead and add the required NuGet package. I'm going to look for Scrutor, and here is the library that you need to install to be able to add support for decorators with dependency injection. So if we go back to our dependency injection code, what we need to do to enable Scrutor is say services decorate. And when we call this method, we need to specify two arguments. The first is which interface we are decorating or which service we are decorating. In this case, we want to decorate the member repository interface, and the decorating service or the implementation is the caching member repository. And what this method is going to do, if you take a look at the documentation, is it's going to decorate all the registered services of the iMember repository interface, which is the service registration to the member repository class in the previous line, and is going to decorate this class with the specified decorator. In our case, this is the caching member repository decorator. You can also use Scrutor to simplify your dependency injection code by calling the scan method. It gives me access to the type source selector, which I can use to say from assemblies, and now I can define some assemblies that I want to scan. For example, I'm going to scan the infrastructure assembly by using the assembly reference, and I can also use the persistence assembly and scan that. So this will scan these two assemblies and give me access to the types inside. I can also say if I can include non-public members by passing false for the public only parameter. And now that I have access to my classes, I can tell Scrutor how to register them with dependency injection. For example, I can define a registration strategy, and I like to use the registration strategy of skip if I'm already manually adding some services to dependency injection like I am here. So now Scrutor is going to find these classes, but because they are already registered and I'm using this registration strategy, it's going to skip them and not register them with dependency injection. Then I can say how I want to register these services, and the preferred approach that I like to use is as matching interfaces. What this is going to do is when it finds a class called attendee repository, it's going to register it as an implementation of the iAttendee repository service. So the naming convention that Scrutor uses is if it finds a class with a given name, it's going to register it as an implementation of the iClass name interface, which means that I can get rid of all of these definitions here and replace them with this call to Scrutor. And I can also define my service lifetime, and because they were all scoped, let's call the with scoped lifetime method. And now let me show you how the decorator actually works when we start the application. So if I send a GET request from Postman to fetch a member with this identifier, and it's not currently present in the cache, I expect my implementation to head to the database and fetch the member from the database. So let's send this request, and you'll see that we first land inside of the caching member repository. Another thing I want you to observe is that if I hover over the member repository, which we injected in the constructor, you'll see that the implementation that was provided was the member repository class, which is our decorated type. If I press continue, we're going to land inside of the function to generate our cached value. And this happened because we encountered a cache miss, and then we're going to head over to our member repository implementation, which is going to use EF core to obtain this value from the database. So if I press continue, we're going to get the result back in Postman. And if I send this request again, we're going to again hit the breakpoint inside of the caching member repository. But if I press continue, you'll see that we get the response back in Postman immediately, and we don't head over to the base implementation of the member repository because the value is already cached and we are reading it from memory. So the value of introducing caching is improved performance because we can read values from memory, which is much faster than querying them from the database. And we also reduce the load on the database because we aren't querying data from the database as frequently for the cached values. Now, the downside of introducing caching is now you have to deal with cache expirations, stale values in the cache, updating the cache entries when an update occurs. I'm not going to solve those problems in this video, but I want to highlight one more thing, and this is the fact that we are leveraging EF core in this implementation. For Entity Framework core to be able to track changes to your entities, they need to be added to the change tracker. This won't be happening if you are returning your values from a cache. So definitely consider if you need to attach this value to the current database context for your updates to work properly. If you don't want to attach this value every time, there's an alternative solution, and this is calling the update method whenever you want to update your cached value. So in this case, I'm getting the cached member using my caching member repository, and I'm updating the first and last name. This will only work because I'm calling the update method, which is going to call the respective update method on the database context, and the update method will add this entity to the change tracker, meaning that any changes will be persisted to the database. If you want to learn how to implement proper caching using Redis, take a look at this video here, which explains this concept in depth, and make sure to smash the like and subscribe buttons, and until next time, stay awesome.